Hello, my dear students. Welcome back to the lecture. So in this lecture, we will see how to prepare the BBS for the staircase. Okay. So before that, we need to understand the plan that is given. This is a plan what I have, and these are the steps what we can see here. And the width of each of the flight. This is flight number 1, and this is flight number 2. So it is 1200. This is given as 1200. Okay. Each of the flight is given 1200, and this is a going part. That means you will take your stairs from here. This is your flight number 1. From here to here, the distance is 2230, right? And then coming to the other part, that is a cross section part. They have given here. So there is some mistake in my AutoCAD. Every time this pops up, so just bear with this. Okay. Yeah. So first what I'll try to find, say there are different bars in this, okay? Now first my intention is to find the cutting length of this particular bar, this yellow color bar, whatever you can see, right, which has come here. First we'll try to find the cutting length of this particular bar. But before that, I need to understand what is this inclined length from here to here. I want to understand what is the inclined length from here to here. If I find this length, only then I can find this particular length. Okay. So for that, what we have to do is, we know from the top, this is my plinth beam. Okay. This much area, whatever you can see, right? So this is my plinth beam. So we know one thing, from the top of the plinth beam to the top of the landing slab, this height is 1524. Okay. One thing we understood from the drawing, that is from the top of the plinth beam to the top of your mid landing level, this height is 1524. Also, from the first step, this is your first step, isn't it? From the first step to this center of the beam, okay, this is your mid landing beam what we have. From the center of that beam, this going in the sense how much steps you are going to take, that is also given, which is 2230 mm. Okay, so two things we understood. So with these two things, I can find this particular length. So how we are going to do? I'll do it very simple now. See, this height I know, from this top to this top height I know. Agree with me? Then again, from the first step to this particular part, I know it is 2230. Now, if I try to draw a hypotenuse, can I not get this particular length from here to here? I can get it easily by using Pythagoras theorem. This height I know, which is 1524. This length I know, which is 2230. I'll do a calculation of square root of 2230 plus square root of 1524. This particular length from here to here, I'm going to get. Okay, fine. So we'll quickly do that. What you're supposed to do, write SQRT, square root of, first I'll write this one, 1524 whole square. Okay, whole square I'll write like this, plus what is the second one? Second one is 2230 whole square. So try to do these calculations and tell me what is the answer you're getting. So let me do that. What you can do is 1524 whole square plus 2230 whole square. You try to do whatever answer you get. No, you put a under root to that answer. I'm getting 2701. So whatever I'm getting is 2701 mm. Got it? So this is the inclined length what I have, which is from here to here, it is 2701. Understood? Great. Now, the thing is that since it's a parallel, like this particular slope, what is going from here, okay, this particular slope, what is going from here, and this particular bar, what I have, they're almost parallel to each other. That means whatever length I got now, this length, that is 2701, is same from here to here. You're getting my point? So let me repeat that once again. So whatever slope I got, or whatever inclined length I got, that is from here to here, okay, from here to here, is almost same, or it is equal to this particular length from here to here. Okay. So how did I do that? Because since both are parallel, they're parallel to each other, and we know the simple mathematics, if both are parallel, then whatever length you got for this is the same length for that also. So that means this particular length from here to here, this particular length of the yellow bar from here to, yeah, just bear with me because there is no solution to that problem as of now. So it keeps on popping up. From here to here, this length is also 2701. So one thing we understood, that length what we got is 2701. Okay, very simple. Fine. After that, I need to find which particular length. This length is done. Next, I want to find this particular length, which is that this particular length from here to here. So how we are going to find this particular length from here to here? It's very simple. We know this is 910 mm. This particular length from here to here, it is 910 mm. So from this, if I remove one cover, if I take out one cover from here, since it's a landing slab and it is a staircase, we provide a cover of 20 mm. So out of 910, if I remove or if I deduct 20 mm, I'm going to get this particular length from here to here. Got it? So two things you understood. One is this inclined length we got from here to here, and this length also I got. So two things I got. Next, the third part which is left out is from this part. The third part which is left out is, yeah, the third part what is left out is from this to this length I am supposed to find. So how we are going to find that, that I'll explain you. But as of now, we understood two things. That is, one is the inclined length I came to know, and I came to know even this length. Now let me start with this particular section. That is how we are going to find this particular length. Okay. So for that, you need to do certain calculations and where you need to bring in the angle part and also, and I'll explain you how it has to be done. Okay. Fine. So let us start with something like this. So whatever you can see here, no, this actually bar should have come somewhere here. It will look something like this. Okay, I'll show you. I'll show you one more image for that, since the drawing is a little bit not that easy from here. Actually, this bar, whatever you can see, isn't it? This bar should have been something like, I mean, same thing. It will be something like this. I'll put it in this way. Okay, this length we have found. Try to understand. It's very simple. Just you have to practice once or twice. This length we found now, which is 2701. Then again, this length also I found. That is 910 minus 20 mm I did. This much you have understood. Last one part which is left out is this one. This part. From here to here. And this part I'm supposed to find. So for that, what I'm supposed to do? For that, I need to find the angle uh, through which this particular bar is laying. I need to find this particular angle. If I find this particular angle, only then I can find this particular length. And if I can find this particular length, then I can find this also. So for that, one simple thing what we need to do is we need to find the angle of this stair. That is, in which angle your waist slab is coming. That angle I'm supposed to find. That is this particular angle I'm supposed to find. If I find this angle, only then I'll be able to do that. For that, we can do a very simple calculation. That is, to find this angle, what I'll do is, this angle I'll write it as tan theta. This angle I'll find. Okay. So let us say this angle, what I want to find is tan theta. So what is tan theta? For tan theta, I'll write it here. So tan theta in the sense, tan theta, I'll write Q. Tan theta is equal to, always it is opposite by base, isn't it? Now what is my tan Q? So tan Q will be, what is opposite? So opposite is 1524. Yeah. So this is opposite for me. This height, whatever you have, no, this is 1524. Okay. You're getting my point, isn't it? So opposite is 1524. Divide by, what is our base? So base is this one, 2230. Whatever we found, no, same thing. But here we are, since I want angle, so I'm putting a formula called as tan theta. I want to find with slope, this staircase is being put. So this height I know. Let me do it in this way. This height I know. This length also I knew. I want to find this particular length, that already I've found. But this angle I'm supposed to find. To find that angle, what I've done, this length I've taken, this height I knew. With this, I'll put a formula called as tan theta. So tan theta is equal to this opposite by base. So it will come out to be, this is 1524, this height is 1524, and base is 2230. So try to do this calculation. You're supposed to get an answer of, so what will happen if I want theta, that is Q. Q is equal to, it will be tan inverse. Okay, that basic calculation I hope you are knowing. When tan goes to the other side, it becomes tan inverse. So it is tan inverse of 1524 divided by 2230. So try to do this calculation and tell me what is the angle you are getting. So once you do this calculation, your angle Q will be 34.34 degree. Okay, 34.34 degree. So that means the slope in which this staircase waist slab is being put is at the angle of 34.34 degree. So once I get this degree, only then I can do the remaining calculation. This much you understood? Great. Okay. So try to do up to here. After that, in the next lecture, I'll teach you how to go with this remaining part, because again, I don't want to stretch this particular lecture. So once I find this area, I'll give you an just what I'm going to explain in the next lecture. So this angle I know, this angle is 34.34 now. So with this angle, what I'll do, I'll try to find this particular length. For that, again, I'll put an angle. I'll try to draw a line here and I'll try to put this line. Okay. And first, let me try to find this particular base. If I find this base, I can find this thing because I already know the angle, because whatever angle is being put, that is 34.34, these bars are being laid at an angle of 34.34. That means I know the angle. I can find the base because the breadth of the plinth beam is also given in your drawing. So with the help of that, I can find this particular height. Okay. So I've just given you an idea what we are going to do in the next lecture. With this, we can find this particular thing. So once you find this, again, it's very simple. You will be knowing the base. You'll be knowing the opposite side. With this, you can find this inclined length. Okay, right now, I cannot find the inclined length because I have two unknowns. So if you want to find anything, you should be knowing, there should be only one unknown. But right now, I don't know what is this length. I don't know what is this length. Also, I don't know what is this length. But I know there is one something called as angle with which this bar has been laid. And this base, I can do some circus and I can get the length of the base. And through that, I'm going to find this particular height. And then if I get this thing and this thing, I can find this one. Got it? So try to practice up to here. It is very simple. Your staircase is a bit simple, but it is a bit tedious. You need to apply a lot of angle calculations here. But once you practice it for once or twice, it will be very simple. Okay. Initially, now you may feel like, oh, there are a lot of bars, how I can do all those things. But trust me, by the time we finish the staircase, this part becomes very easy for you. Okay. So we'll see you back in the next lecture. Thank you.